What if gravity no longer held us down? A machine that walks on walls, moves with impossible balance, and seems to rewrite the laws of motion, it's not science fiction anymore. China's latest technological breakthrough, Unitree's anti-gravity AI robot, is taking the world by storm. This isn't just another step forward in robotics. It's a leap into a new era of artificial intelligence and physics-defying design. While most robots struggle to walk upstairs, this one climbs surfaces, hovers inches above the ground, and learns to move better every day through AI-driven adaptation. The moment you see it in action, one thought hits you. The future has arrived. The birth of a revolution. The world has seen Boston Dynamics Atlas perform parkour, Tesla's Optimus learn basic motor control, and humanoid assistants like Figure 01 and Agility Robotics Digit take center stage. But China's robotics industry has now entered the global spotlight, and this time, it's rewriting the rulebook. Meet Unitree, the same company that created the famous quadruped robot, Go-1, known as the budget version of Spot. But now Unitree has unveiled something truly futuristic, an anti-gravity AI robot that fuses advanced machine learning, motion prediction, and magnetic levitation technology to achieve balance and movement like nothing we've ever seen. Concept sounds almost impossible. A robot that doesn't fully rely on physical legs to stay upright, but instead uses micro-thrust, adaptive stabilization, and AI prediction to appear as if it's floating. Yet engineers and researchers confirm it's real, and it's functional. The shockwave. The reveal of the Unitree anti-gravity robot sent immediate shockwaves through the global tech community. Demonstrations at robotics expos in Shanghai and Beijing showed the robot performing complex maneuvers, hovering slightly above the ground, moving seamlessly over obstacles, and balancing on one foot while pivoting 360 degrees. At first, many assumed the videos were enhanced. How could a mid-sized robot, powered by standard lithium-ion cells, defy gravity? But as journalists and engineers were invited for live demonstrations, the skepticism turned into astonishment. The secret lies in Unitree's breakthrough hybrid design, a combination of electromagnetic suspension, AI-driven gyroscopic balancing, and predictive neural modeling. In simpler terms, it reads the environment, anticipates gravity's pull, and adjusts its internal systems in milliseconds to maintain perfect balance. This allows it to do what traditional robots simply cannot: move with grace, fluidity, and awareness. Inside the machine, let's break down what makes this possible. At the heart of the Unitree anti-gravity robot is a new AI motion engine trained on billions of hours of biomechanical data from human movement, animal motion, and even drone stabilization algorithms. The robot doesn't follow commands in the old sense. It predicts what it should do next based on how its surroundings are changing in real time. Its internal core uses micromagnetic levitation units, which create small, controlled magnetic fields that reduce effective ground friction by up to 80%. Combined with adaptive air thrust valves similar to those used in microdrones, the system gives the illusion of weight reduction. It's not true anti-gravity, of course, but functionally, it behaves as if gravity's pull is dramatically lessened. Each movement is computed by its neural coordination processor, a system designed to mimic the human cerebellum. This enables learning through trial, correction, and reinforcement, meaning every step it takes makes it smarter, smoother, and more stable. What truly makes the Unitree robot revolutionary isn't its hardware, it's its mind. Traditional robots rely on preset algorithms and motion libraries. Unitree's new AI model doesn't. It uses reinforcement learning to build its own movement strategies. If it slips, it remembers why. If it balances better next time, it improves upon that learning. In early tests, researchers observed something unexpected. The robot began developing unique movement personalities. Some units walk cautiously, others move fast and aggressively, depending on how their neural model evolved during training. This marks a major step toward autonomous motor intelligence, where robots aren't just following commands but developing preferences based on environmental feedback. Unitree's engineers compare it to a baby learning to walk. At first clumsy, then confident, until suddenly it's sprinting. Except in this case, the baby never forgets, never tires, and learns millions of times faster. Power and performance. Despite its delicate balance and smooth mobility, the robot is a powerhouse under the hood. It runs on a next-generation solid-state battery system, giving it up to 8 hours of continuous operation. The lightweight carbon fiber frame keeps it strong yet flexible, while advanced cooling systems ensure stability even under heavy load. Its AI coprocessor, developed in collaboration with Chinese chipmaker Horizon Robotics, gives it unmatched computing efficiency. The processor handles real-time environmental mapping, predictive physics simulation, and natural language interaction simultaneously. In simple terms, the robot can analyze its terrain, predict how gravity will affect each motion, and talk to you all at once. Even more impressive, its energy efficiency allows it to operate with minimal heat and noise, crucial for indoor or public use. Compared to its American rivals, it consumes nearly 40% less power while delivering smoother motion accuracy from industry to everyday life. So what can this robot actually do? The answer, nearly anything that involves physical movement and adaptive balance. In industrial sectors, it can navigate uneven terrain, climb structures, and perform inspections where drones or humans can't safely reach. In logistics, it can move through warehouses or production floors, handling delicate materials without collisions. But the biggest surprise is in the consumer space. With costs expected to be under $10,000, the anti-gravity robot could become part of households, assisting in cleaning, caring, security, or companionship. Its ability to balance and adjust movement means it can safely navigate around pets, furniture, and people, something even premium robots struggle to do. What this means for the world. The Unitree anti-gravity robot signals something much bigger than a single invention. It marks the beginning of a new robotics era where physics itself becomes flexible. If machines can now mimic the human ability to balance, stabilize, and move intuitively, the line between biological and mechanical agility begins to blur. China's rapid development in AI robotics also poses a strategic question for the rest of the world. For decades, advanced robotics was dominated by Japan, South Korea, and the US. Now China has entered not just as a competitor, but as an innovator pushing boundaries once thought impossible. This shift could redefine global technology balance. In education, healthcare, and even defense, a robot that can move effortlessly and think on its feet changes how nations prepare for the future, not just economically, but militarily and socially. The hidden risks. But there's another side to this story, the risk of acceleration. When AI and robotics evolve faster than regulation or ethics can keep up, unexpected consequences follow. Experts warn that advanced autonomous systems like this can outpace current safety standards. A machine capable of independent learning and physical adaptability might behave unpredictably in new environments. What if it misinterprets a command? What if its self-learning leads to unintended actions? Then there's the question of dependency. As these robots become affordable and widespread, society may quickly rely on them for household chores, factory work, and even emotional companionship. And once that dependency begins, reversing it becomes nearly impossible. It's not just about technology anymore. It's about reshaping human life. Global response. Since Unitree's demonstration, major robotics firms across Japan, South Korea, and the US have accelerated their own projects. Boston Dynamics is reportedly developing a new model with AI-driven balance simulation, while Tesla's Optimus division is testing neural learning upgrades similar to Unitree's system. China's Ministry of Industry and Information Technology, MIIT, has hinted at establishing global export partnerships for its next-generation robotics line, including the anti-gravity unit. That means this technology may soon enter international markets faster than anyone expected. And make no mistake, this is not just competition, it's a technological arms race. Whoever perfects physical AI will dominate the automation economy for decades. Robotics is no longer about convenience, it's about global influence, the future. So where does it all go from here? According to Unitree's internal roadmap, the next leap isn't just about movement, it's about emotion. The company is developing AI emotion mapping, a system designed to help robots understand and respond to human feelings. Imagine a machine that doesn't just react to your words, but senses your tone, detects your stress, and adjusts its behavior accordingly. When combined with its near-frictionless, gravity-defying mobility, this could lead to robots that act as true companions, from healthcare assistants that comfort patients to AI teachers that understand a student's frustration and adapt in real time. But beyond imagination lies a deeper transformation, the fusion of intelligence and motion into one living system. Once a robot can learn, adapt, and move like a living being, it crosses a line between programmed behavior and organic response. That's not just technological progress. It's a shift in how we define life and intelligence. For many, this vision sparks excitement and endless possibility. For others, it raises fear of dependence, of displacement, or of blurring the line between human and machine. Yet one truth remains clear. The era of grounded robotics is ending. The next generation of machines won't just walk beside us. They'll soar, glide, and evolve with us. Whether we're ready or not, the future of robotics is no longer bound by gravity. It's taking flight. The Unitree anti-gravity AI robot isn't just another piece of advanced machinery, it's a statement to the world. It proves that what once seemed impossible is now within reach. The barriers of movement, balance, and control are being rewritten, not by massive labs with endless budgets, but by innovators daring to think beyond the rules of physics. Sure, gravity still holds us down, but for robots like this, the concept of limitation is quickly disappearing. As technology continues to learn, adapt, and evolve, we're witnessing the start of a new chapter in human progress. A chapter where machines not only assist us, but challenge our understanding of what's physically possible. So the real question isn't if we'll live alongside intelligent, gravity-defying robots, it's when. And more importantly, are we prepared for the world they're about to create? If you enjoyed this deep dive into the future of robotics, don't forget to like, share, and subscribe for more mind-blowing tech content. Thanks for watching and stay tuned, because the future is already here.